Hello student, I am Assistant Professor Fatima Tamboli and welcome to the first lecture of Chapter 1 Introduction. In this chapter, we will learn operating system structure, then virtual machines and system boot. So, what is the objective of this chapter? To discuss the various ways of structuring an OS and to explain how OS are installed and customized and how they boot. So first is the structure. First structure is a simple structure. Example of this OS is MS-DOS. It is written to provide the most functionality in the least space. That means it provides the most functions, but it uses the minimum space. Then it is not divided into the modules. Then it has some structure. Its interfaces and levels of functionality are not well separated. That means there is a no module and it is very simple structure. Now this is the diagram of layer structure of MS-DOS. So here there is an application program. They communicate with the resident system program. This is the MS-DOS system program. Then after that there is a MS-DOS device driver. They are used to communicate with the device. Next is the layered approach. The operating system is divided into a number of layers or levels, each built on top of lower layers. The bottom layer, it is also called as layer 0, is the hardware, and the highest layer is the user interface. With modularity, layers are selected such that each uses the functions and services of only lower level layers. This is the diagram of layered operating system. So at layer 0, hardware is there. Then there is a layer 1 up to layer n. Now layer n is nothing but the user interface. Now lower layer, that is hardware layer, provides the service to the layer 1 and so on. Example of this operating system is Unix. Unix, it uses the limited hardware functionality, and the original Unix operating system had limited structuring. The Unix OS consists of two main parts, system programs and the kernel. System program contains the compiler, interpreter, etc. And the kernel is the heart of the OS. It consists of everything below the system call interface and above the physical hardware. It provides the file system, CPU scheduling, memory management, and other operating system functions. A large number of functions for one level. This is the diagram of Unix system structure. So here is the user, then next is the shells and commands and compilers and interpreters, that means system program. Next is the kernel. So here system call interface to the kernel. So in a kernel, there is a signal terminal handling, then character input output system, then terminal drivers, then there is a file system, swapping block IO systems, disk and tape drivers. Then it performs the CPU scheduling, page replacement, demand paging, and virtual memory. After that, there is a kernel interface to the hardware. Then hardware contains the different terminal controllers, terminals, device controllers, disk and tapes, memory controllers, and physical memory. Next structure is a microkernel system structure. It moves as much from the kernel into user space. Communication takes place between user modules using message passing. So there is a difference, that is user space and kernel space. Benefits: it is easier to extend a microkernel, easier to port the operating system to the new architectures, and it is more reliable. It uses the less code, then it is more secure. Then its performance overhead of user space to kernel space communication is a disadvantage. This is the example of microkernel structure, that is Mac OS structure. So in the diagram, we can see that kernel environment is different and user environment is different. Next is the modules. Most modern operating system implements the kernel modules. It uses the object-oriented approach. Each core component is a separate. Each talks to the other over known interfaces. Each is loadable as needed within the kernel. overall similar to layers but with more flexible. That means here operating system is divided into the different modules. Example of this is the Solaris module. So here core Solaris kernel is a one module, then scheduling classes is the another module, then file system is the another module, then loadable system call is another module, executable format is module, then stream module, then device and drivers and other components will be comes under this module. So here it is divided into the different modules. Thank you.